All right, so let's jump right in. We're talking about a math problem that for 200 years, everyone just knew was impossible to solve. I mean, it was like a fundamental law of algebra. But what if that law wasn't really a law at all? What if it was all based on, well, a misunderstanding?
I mean, think about it. What happens when something we've taken as a mathematical fact for generations just isn't? That's the heart of what we're digging into here, because a truth that has stood for centuries is now being challenged in a huge way.
So here's the deal. For 2 centuries, if you had a really complex equation, mathematicians would tell you, look, we can't solve that exactly. They had to settle for getting close. But now, someone has stepped up and claimed, actually, we can find the perfect answer. And if that's true, well, that changes basically everything. Okay, so to really get why this is such a massive deal, we've got to go back in time. Let's look at the origin of this unsolvable equation.
The year is 1824, and a brilliant Norwegian mathematician, Niels Henrik Abel, completely rocks the math world. He basically proves that there's no magic formula, no single key that can solve every polynomial equation once you get to the 5th degree or higher.
And just like that, his proof drew a line in the sand. On one side, you've got the equations we all remember from school, right? Quadratics, cubics, the ones where you can actually find a perfect answer for x. But on the other side of that line, the impossible ones. Anything from the 5th degree on up was considered unsolvable in a clean, exact way. So for 200 years, mathematicians had to just settle for close enough.
Yeah, that proof essentially built a wall in the world of mathematics. And for 200 years, everyone just accepted it as a fundamental fact of algebra. The end of the road.
This wall actually has a name. It's called Abel's impossibility theorem. And here's the crucial part. The theorem doesn't say solutions don't exist. It just says you can't find them with a single, neat formula using the standard tools in your math toolkit. You know, adding, subtracting, multiplying, and taking roots like square roots or cube roots. And for 2 centuries, that was that. Case closed.
So why couldn't they crack it? Well, imagine trying to build a skyscraper with just a hammer and a screwdriver. As these equations got more and more complex, their deep internal structure, what the pros call their Galois group, just got way too complicated for those simple tools. The complexity literally exploded. So everyone just gave up on finding a perfect answer and switched to making really, really good guesses, numerical approximations. The dream of exactness was basically dead.
But then, along comes Professor Mourad Sultan Ezouidi. He looks at this 200-year-old wall, and he doesn't see a dead end. He sees a puzzle to be solved, and he came up with a whole new way of thinking, a new framework to just smash right through it.
And this quote from him really gets to the heart of it. He says, "I have never accepted that limitation. The problem was not the equation itself, it was the limitation of the mathematical tools available at that time." See, he isn't saying Abel was wrong. He's saying the toolbox they were using back then, it just wasn't big enough.
And this is where you see the huge difference. The old way said impossible. Ezouidi's theorem says, hold on, we can get an exact symbolic solution. The old way gave you a good guess. This new way gives you a 100% verifiable, perfect answer. But honestly, the biggest change is philosophical. It's about rejecting this idea of mathematical fatalism, as he calls it. This idea that some problems are just meant to be unsolvable.
Okay, so that's all the theory, which sounds great. But the real question is, does it actually work? Let's get to the good part, watching him solve the impossible.
Whoa! Okay, don't let your eyes glaze over. Yes, this is a monster of a 20th degree polynomial, and that's exactly the point. This is the perfect test case because with the old methods, finding an exact answer to this thing, it was completely unthinkable. This is the Mount Everest we've been talking about.
So how in the world does he do it? Look, the math itself is super dense, but the big idea behind it is actually pretty elegant. Instead of attacking the whole thing head-on, his method first reorganizes the equation structure. Then it starts applying these special transformations over and over again, simplifying it one layer at a time. It's kind of like peeling an onion until you get to the very core. And once you're there, the exact answers just pop out.
And there it is. That's the solution. The trophy at the end of the race. This is the exact symbolic answer to that huge polynomial. And that's the whole point. It's not a close enough, it's not a long string of decimals that goes on forever. It's a perfect, clean algebraic expression. This is the proof in the pudding. It's the flag planted on top of Mount Everest.
So, solving one crazy equation is cool, but this is so much bigger than that. Let's zoom out a bit and talk about what this could change forever.
Okay, this is what you really need to take away from all this. If this holds up, it's a complete game changer. First, it just demolishes a 200-year-old mathematical consensus. Second, it means that every single polynomial, no matter how ridiculously complex, probably has a perfect, exact answer just waiting to be discovered. It would shift mathematics away from just getting close enough and back to its core purpose, finding perfect, beautiful solutions. And maybe the biggest thing, it forces us to ask what other problems that we think are impossible are really just waiting for someone to come along with a new way of looking at them.
And that really brings us to the final question, doesn't it? This whole story, it's not just about a tricky math problem. It's about how we define what's possible in the first place. It really makes you wonder, what other impossible walls are out there just waiting for someone to come along with a fresh pair of eyes and see a doorway?